So, hello sir, myself Tejas Rajanakar. Today's topic for SCE of mechanical vibration is simulating modeling of 2 degree of freedom mass spring damper system. So, talking about introductory part or theory part, there are many systems which require multiple number of coordinates to express the motion in the world. There are many examples of a system which is having 2 degree of freedom to describe the motion. It requires two equation of motion. The example of 2 degree of freedom which I used to model on Simulink is as follow. So this is my equation, which is m1 into x1 double dot is equals to minus k1 into x1 minus c2 minus c1 into x1 plus k2 into x2 minus x1 plus c2 into x2 dot minus x1 dot, and second equation is m2 into x2 double dot is equals to minus k2 into x2 minus x1 minus c2 into x2 dot minus x1 dot plus f. So this was the equation. My problem statement is to build a Simulink in a Simscape model for 2 degree of freedom mass spring damper. And the given data is M1 is equal to 10 kg, M2 is equal to 30 kg, F is equal to 10 Newton, K1 is equal to 100 Newton meter per Newton per meter, K2 is equal to 300 Newton per meter, C1 is equal to 5 Newton second per meter, C2 is equal to 3 Newton second per meter, C3 is equals to 2 Newton second per meter. And this is the schematic of my problem statement, which was random. So this was the introductory part, problem statement and equation. So now moving towards the Simulink part. So this is the Simulink, and for that, first of all, I open the MATLAB, then I go to the editor window, then I put the input parameter and press the run button. After pressing the run button, this will allow me to input in a Simulink. After that, I came to the home button, then I went to the Simulink. Then to take these blocks, there are two methods in which first is we have to go to the library and search the blocks, or we have to double tap on screen and search. So after that, and we have to set the step back time, stop time. So this was the introductory part of Simulink. So in this model, I used simulation. Sorry, I used the summation block. So this is summation block. This is summation block. After that, this is a gain block. After that, this is integrator. This one is to integrator. This one is also summation block. Then this one is step block, and last one, this one is scope, which will give the result. After that, the result of first sum block is given to gain mass, which will give the m1 into x1 double dot. After that, this gain result is given to the integrator, which gives the displacement. So this was the first part. After that, the integrator block of velocity, we got the velocity, and it is multiplied with the damping coefficient with first system, which results in the C1 into x1 dot. And we know that it is as our equation, C1 into x1 dot is having negative sign, so we connected it to the connecting that to the negative part of the first sum block. So after that, the integrator block is block of displacement we got the displacement, and it is multiplied with the damping coefficient with the first system. After that, this results into the k1 into x1, and we know that as per our equation, k1 into x1 is having also a negative sign. So we connected that output to the negative part of the first block. So this negative are connected. Hope we got the result in this type, like this type. So this was the Simulink model, and this is the result which we have got. So the display of result for the first spring mass system, and after that, by changing input, we got this type of result. So this Simscape model. So about Simscape model, in which first is a mechanical translation reference. This block represents the mechanical translation reference point, that is a frame or a ground used to connect the mechanical translation port that are rigidly affixed to the frame or ground. So second one is spring. This block represent the ideal mechanical liner spring. Then after that, damper. This block represent the ideal mechanical translation viscous damper. Third one is fourth one is mass. This block represent the ideal mechanical translation mass. Then fifth one is the ideal translation motion sensor. This block measures the velocity or the displacement into in a mechanical translation work network. Sixth one is a ideal force resource. Uh, this block represents an ideal source of force in the sense that that is assumed to be powerful enough to maintain a specified force regardless of the velocity at source terminal. Seventh one is PS constant. This block creates the physical signal constant. And last one is solver configuration, which defines the solver setting to use for simulation. So this was all about from my side. So moving towards the conclusion part. So the conclusion was by comparing the result of both the Simulink and Simscape model, the velocity of the velocity required for 2 degree of system can be determined. There is a similarity in the result obtained by both Simulink and Simscape. So this was from my side. Thank you.